Welcome to this module of Professor Messer's free CompTIA A+ certification training course on configuring and installing routers and access points. I'm James Messer, and in this module, we're going to go through our requirements from our CompTIA A+ 22702. That's our practical application exam, section 3.2. And this really focuses on how to set up and configure a small office, home office network, something that you might have at a remote location. We're going to focus on the security aspects of that and the networking aspects of that, configuring the router pieces, the access point wireless connectivity, the firewall features. And we're going to go through IP address settings, SSID broadcasting configurations, MAC filtering, firmware upgrades, and much more in this module. There are a number of security features built into these access points, these wireless devices, and these firewalls, and we really do use them as an all-in-one device. And they not only become a very important connectivity device for us, but they also become a very important security concern for us. We are not only connecting to the internet, which has a danger unto itself, but we're also using a number of wireless features with this as well. And as you may recall with some of our other videos, we've mentioned having that wireless connectivity, you're sending out radio signals. And if somebody was outside your home with the right type of software and hardware, they may be able to listen to what you're doing. Now, the important thing is, even if they're listening, we want to be sure they're not able to even read anything with encryption. So we've discussed encryption and some of those capabilities in the past, but there are other security features we can turn on to make it a little bit more secure. Let's step through some of those features. Let's start with the IP addressing configurations that are inside of these wireless access points and these routers. What we normally see on our workstations whenever we're connecting to a network is automatic addressing using the DHCP protocol, the Dynamic Host Configuration Protocol. And that's normally what you'd have. You would set up your wireless network so that anybody who had a computer could sit down on that network, and as long as they had the proper encryption keys, they could connect to the network and at that point get the IP address that would be automatically assigned to them. What some people will do as a bit of a security concern is make the IP addressing manual and maybe change some of the IP addressing subnets on the firewall and the router so they're not defaults. That way, even if somebody was to connect onto this network, they at least would not initially have an IP address and would not be able to communicate on this network. The problem is that if it's an unencrypted wireless network, you can sniff the air. You can grab packets right out of the air and see very easily what the IP addresses are that people are using. And from that point, it's not a very difficult guessing game to determine what IP addressing that people are using. If somebody has gotten onto your network that is encrypted, then they're seeing all of this traffic anyway. It's almost the same as being on an unencrypted network because they're already in. They've got the right access key, the right encryption piece put into their workstation. They're going to see everything anyway. And because of that, this is not exactly a security feature as much as it is an obscurity capability. In the security world, we call security through obscurity is really not security at all. It's really just a way to hide things from the people who don't know where exactly to look. If I put something behind my back, you may not be able to see it, but you know there's something behind my back, and all you really have to do is look behind me to see exactly what's going on. That's a lot of what this IP addressing capability is. But we can also adjust IP addressing for our external configuration out to our internet. So there's a few places to look at IP addressing. Let's look at what it's configured as on my access point, my router, and we'll look at all the different places where you might configure some of those IP addressing configurations. Let's first connect to my wireless access point. I have a Google screen up here, so I need to change my IP address up here to be the IP address of my router. And it tells me that the server at 192.168.0.1, it's a WGR614v4. So already I know a little bit about the hardware that I'm using here. Probably not the best idea to put that into the banner, but that's how this device it works. That's how it's built in. I use a default username for this device. This is a Netgear device, and all of the Netgear devices use a default username as admin. We'll talk about that in just a moment. And then you put in the password, and there's a default password that's used for all of the Netgear devices. I am not using that default, and we'll also look at changing those passwords too. Once I log in, I get this login screen, this main menu that I can then choose from on the left-hand side with all of these different configurations. And the basic settings page is a good place to start. We can see in the basic settings that I can configure things like account names and domain names if necessary. Some internet service providers require that you put that information in there. Mine does not. I get my IP address dynamically from my ISP. I simply connect to my internet service provider and I request an IP address, and one is automatically given to me. And you can see those numbers are filled in here, not just the IP address, but the subnet mask and the gateway IP addresses as well. I could also ask for my domain name servers to get automatically from my ISP. In my case, I use OpenDNS, which is a free service that allows me to do some URL filtering so that inside of my network, there are certain websites that you cannot go to. It's an administrative function that I use inside of my home. And so I set up a primary and a secondary DNS here so that it must go to OpenDNS to do that. Also, you can see that I can use the router's MAC address, the default address, a computer's MAC address. And at some point in my trials and testing, I decided that I wanted to hard code the IP address to be this. And there may be a number of reasons why I did that, although at this point I have no idea what that could be. Normally, you don't have to change that at all, though. You can simply use the default address, and it will use whatever the built-in MAC address is for this particular router. But that's not the IP addresses that I'm worried about. The IP addresses I'm concerned about are the ones that are on my wireless network. So I'm going to click way down here. There's a LAN IP setup link, and you can see here is where I am setting up the LAN configuration, all of the IP addresses that are on the inside of this particular firewall. And you can see on the inside, the IP address that's the primary IP address for the IP setup, that's where we're connecting to right now, is 192.168.0.1. And the subnet mask is one that I've just assigned. I've assigned it a Class B address because I'm doing some other things in my lab here. Normally, the default would be a 255, 255, 255.0. But these are the configurations I set up just to connect to the device. When people are on my network, they're going to be using the DHCP server addresses. So these were the ones that we were just talking about earlier with either enabling or disabling this DHCP capability. You can see I can turn that on or off right here to use the router as a DHCP server. My starting IP address, 192.168.0.2. My ending IP address, 192.168.0.51. And if you wanted to always have a certain workstation, always have a certain IP address, you could set up an address reservation that said, if you're this IP address and we're going to call you by this name, and if you have this MAC address, we're going to make sure all of those will match up. And that way, every time that particular workstation connects to the network, it will always get exactly the same IP address. Sometimes I'll see people use printers this way when they want to be sure they know the IP address of the printer every time. And they may set it outside of their DHCP server zone. In fact, you really need to if you're assigning these statically. So we might have an address down here reserved that's 192.168.0.52. And that way I know that the only device on my network that could ever get that IP address is this one that I've reserved here. There won't be any overlap with the ones that are handed out automatically via DHCP. Another feature with our wireless networks is SSID management. SSID stands for our Service Set Identifier. And it's really just the name of the wireless network. It's just an easy way for us to assign this. If you go to look at what wireless networks are available, it's the SSID name that pops up in that window. There are a number of default SSIDs. You'll see out there Linksys, Default, Netgear. There are a number that you see that people just don't even bother changing. They just turn it on and plug it in. No encryption. They don't change their SSID. It's very generic, and it becomes a little bit more difficult to manage that way. Plus, everyone can see it if that SSID is turned on. Ideally, you would set this to something that maybe isn't quite so obvious. Don't set it to your name. Don't set it to the address. Don't try to make it so that people could see that name and know that it's in a certain house or it's in a certain office. It should be something relatively generic or something that doesn't obviously point out the exact location of that access point. From a security perspective, we sometimes get concerned about that name popping up in those boxes. What if we didn't want our access point to be automatically discoverable by those other devices? We would need to disable the SSID broadcast. Now, again, this is a piece where we are really just making it harder to see it, but we're not making it impossible. There are certain ways that you could listen to what's going on over the air with the right equipment and software, and you would still be able to know what the SSID is of this device. The only thing that we're really turning off is the ability to automatically discover it in these automated processes we have in our operating systems and our mobile devices. This, again, is security through obscurity, which means there's really no security to this at all. We're just making it harder to find. But at the end of the day, if somebody knows what they're doing, they can very easily figure out what your SSID is. To look at our SSID configuration in these same windows, these menus, I'm going to go down to wireless setup, and I've got a couple of options here. One is to enable the wireless access point, and indeed that's something we should consider. Is anybody on this network really going to use the wireless piece? And if they're not, turn it off. There's no reason to make it accessible to people who may not be in your home. And the second one is the one we're really most interested for this example, enabling or disabling the SSID broadcast. And that's exactly where you would go to turn that off so it would be invisible or turn it back on. Again, it doesn't mean that people won't be able to connect through the wireless network. They would just have to manually type in the SSID for this network to be able to then connect. And if you didn't know that particular SSID, you could still figure it out with the right analysis tools. So again, it's a capability that hides it, but doesn't necessarily make things more secure. Another way to filter or create a more secure environment with our access points is to use something called MAC filtering. MAC stands for Media Access Control, and it's really the hardware address of the devices that are being used over the network. The idea here is that we would provide our router, our access point, with a list of the MAC addresses that have permission to talk on this network. And if your device doesn't match that MAC address, it's simply ignored. This will definitely keep out visitors who don't know that this filtering is in place. They won't even be able to connect to this access point if this doesn't match their MAC address. So there is a security aspect to this. Part of the challenge, though, is on wireless networks with the right software. It's very easy to do this, to listen in to what's happening over the air and find out what MAC addresses people are using. And as we've already seen in the configuration of my device, there are certain devices that allow you to specify what the MAC address is. I could certainly wait for somebody to leave the network and then turn my device on with the MAC address that they were just using, and now I'm on the network. That's a very simple thing to do. Generally, you can figure these things out very, very easily. So again, not exactly a security piece or not something that we should rely on for security, just another thing to have in place to help make it a little more difficult to be able to use this particular network. On my access point, I can find that access list. It's under my advanced wireless settings. We were just looking at the SSID broadcast. This is under setup access list. And if I click on there, I can add every device on my network that might have a name or an IP address that I could say, always have this particular device accessing the wireless network. In fact, it's already found a number of devices that are on my network. And I could simply, if I'd like, just add one and say, yes, you will always have this one as part of the wireless card entry. And that IP address or that MAC address that's in use must match what's in my list for it to be able to work properly on my network. I'm not going to set up a wireless access connection in here, but you can see just how easy it is to get that up and running so that one more layer that we have of security on our wireless network. From a security perspective, you should also consider changing the default username and password as soon as you get the device. When I was logging into mine, you'll notice it was using a different password, and that's because I made sure I wasn't using the default. That would mean anybody who had access to my network would be able to then log into the device, and I certainly don't want that. We need to keep the firmware current. This is the operating system code that our wireless devices use. Most of the time, they have bug fixes in them that can be pretty important. And if you want your access point, your router, your firewall to be running with the latest version of software, to be able to work without any of those known bugs, we may want to make sure that we have the latest firmware on there. We also have configurations inside of our devices to manually assign particular port numbers to go to certain devices on the network, which is also useful if somebody's communicating into your network and you'd like to set up an internal server. You may want to turn that on to be able to redirect that traffic. Another capability of these is something called port forwarding or port triggering. It's a case where we can send traffic out one port, and it may be a custom application or an application that doesn't use the normal communication, that we set up a communication to another device that's out there. It communicates back in, but it communicates back in over a different port. Our device is a firewall. It will drop anything that doesn't come in through the correct port. So sometimes we have to set up a port forwarding rule or a port triggering rule, they're also called, to be able to look for those so that if we ever receive traffic on this particular port, to allow it into the rest of the network. Let's look to see where we might configure some of these things. On my access point, setting the password was pretty easy. There's a set password option right here. It even expects you to know, put in the old password, put in the new password a couple of times, you click apply, and it's changed. It's really that easy to change this. So if you're using the default password today on your access point, you should log in right now, run through this very quick process, and make sure that nobody else can access that. Using the firmware update is also pretty important in here. Let's look at our router status. And you can see on my router status, I'm running a firmware version of 5.007. What I'll do is go out to the Netgear site, make sure that that version of firmware matches what's there. And if it doesn't, I may want to consider upgrading this. So that's an important thing to have available. And usually on the manufacturer's website, they have exactly step-by-step the process you should go through for updating the firmware. Sometimes that's done with a third-party executable. Sometimes that's done by an upgrade process right on the router. It depends on the manufacturer, so check your documentation. Let's look at our port assignments. I have two options down here under advanced. Port forwarding means that I can set up a particular service that on a particular set of port numbers, that if I ever have these particular port numbers in use, always go to this particular IP address as a server that I might have internally. So we could set up all port 80 traffic to go to a web server that we might have set up inside of our network. Even though the outside of the network can't see that server, this port forwarding ensures that if any traffic comes in on that port number, that it's automatically sent to our internal web server. The other port option I have here is port triggering. That means that if I have a outgoing port and that triggers this, I'm looking for a certain start and end port as it's going out. I'm now deciding as soon as I see that, look for traffic coming in a different set of ports and allow it into the network, or don't allow it into the network. You've got the option to enable or disable that. So this really helps with some of those odd applications that require a different incoming set of ports than the ones that were made going out. And that way I'm able to still use those applications, but still keep that security in place for the rest of the firewall. When you're installing your access point, your router, you've got a lot of things to think about. There is, of course, the need to plug it in to wherever the wire happens to be coming in your home. If you have a cable modem, for instance, your cable modem is usually very close to your cable jack. And then on top of that, there may be a wireless piece, which means you may be limited. You may have to put the access point right here, which means that your area that you're able to use this may be this big. And if that's the case, you may want to consider mounting it maybe in the center of the house so you get a wider range. But these are things you have to think about. The access point itself works best if it's up high, if it's not near anything that might restrict the signal from going out. So the surrounding objects have to be taken into account. We can also think about the cable length that we have here. If we want to run things through Ethernet, of course, you're going to have limits there. Ethernet is about 100 meters that we could extend an Ethernet cable. And in most houses, that's not a big deal. That's a very small amount of space considering our living spaces, but on very large areas, that may be a concern, especially you have to go up the wall and across the attic and back down again. So these are things that we have to think about, and where are we going to put this access point? Who's going to be connecting to it? How are they going to be connecting to it? And from there, you can figure out how you're going to really configure this to get the widest range possible so that you can access the network from wherever you need. Let's review some of the topics from this module on configuring and installing routers and access points. Our first question is, how can you hide the wireless router so that it does not appear on any discovery list that you could see? Well, we know that it showed up on that discovery list because we had our SSID enabled. So if we disable the SSID broadcast, then it's no longer going to show up on any of those lists. Our next question is, which firmware version should be used on your firewall? And as a good rule of thumb, as a best practice, we should always make sure that we have the latest version of firmware running on our firewall, access point, and router. And our last question is, how can you determine what ports to forward? Whenever you're doing a port forwarding, or maybe you're doing a port triggering, you should always look at the documentation and know how the application works. Most of the time, your documentation is going to have the information you need about how the application operates at the port level, and that's exactly what you should put into your firewall and configure so that you're able to route that traffic properly. That covers the requirements from our 22702 section 3.2. We've looked at a lot of security features of access points. We've looked at configuring, setting up, and where we should place our wireless access point and router. And we've also looked at some of the more advanced port forwarding and port triggering capabilities inside of these devices. If you'd like to watch any of our absolutely free A+ videos, you'd like to participate in our message boards or much more, you can visit our website at freeaplus.com.